Okay, so this is a bit of information that we are given here. This distance at the bottom was x, and the distance, let's see, this whole side was 14, while this smaller side was 2. So if that smaller side is 2, the whole thing was 14. That meant this must have been 12. So this is the triangle that you're given. There's definitely going to have to be some trig involved to maximize that angle. So because you want to maximize theta, what your goal is you're going to want a function of theta in terms of x, because that'll then be the function that you'll take the derivative of, set it equal to 0 to find the critical points, and so on. So this is sort of just as a reminder here on the side, that's what we want. So this one's a little bit trickier to think about, so there's a couple different ways to do this. Best way that I can think of would be to talk about that angle first as, instead of just theta, let's look at the big angle. That big angle I'm going to just call alpha. And then let's try to look at also this smaller angle, so not the one that's theta, but the smaller one. I'll call that beta. And then with that information, we do know that theta would then be equal to alpha minus beta. And the reason I'm doing that is because both alpha and beta include the right angle in this triangle, and the right angle is what we can use SOHCAHTOA for. So that's sort of the reason behind that, and that's definitely a tricky one to come up with. So let's talk about alpha for a second. I'm going to use cotangent simply because I've done this problem enough. You could have done tangent and actually would have worked just fine. Cotangent had less simplification at the end, so that's why I'm going to go for that. If I were to talk about cotangent of the bigger angle, now remember SOHCAHTOA, so tangent is opposite over adjacent, which means cotangent would be adjacent over opposite, and the big angle would then have the big side of 14. Same thing for the smaller angle, so cotangent of beta, again, would be adjacent divided by opposite. So that's what we have for our cotangent of alpha and beta. And what we want to do is we want theta by itself, so we just have to subtract the two. And because we're talking about maximizing the angle is what we want actually by itself. So what we should do here is actually rewrite both of those. I'm going to go to the next page. I can turn back to this if needed. So I'm going to rewrite both of those to say alpha equals cotangent inverse of x over 14, and then beta would equal cotangent inverse of x over 2. So all that I did here was I just took those two angles right here, the way those were written as cotangent of an angle, and I just rewrote that to be the angle equals cotangent inverse. And so then what I get to do, and I'll try to do that in a different color, is I now know that theta is equal to alpha minus beta. Theta was the bigger angle minus the smaller angle. So now I have theta equals cotangent inverse of x over 14 minus cotangent inverse of x over 2. I now have, excuse me, I now have theta by itself. So this is what I would then continue on with. Okay, how do I find theta prime? Take the derivative. You would have to do chain rule for both of them, but you do know the derivatives for cotangent inverse. Set each of them equal to 0, and then see what happens from there, because you're trying to find the critical points. So I'll sort of leave that as a ... for you guys to continue to actually find, to find the derivatives of each of those. Let's see. So once you found the derivative, what you should, and set it equal to 0, you should have ended up with negative 14 over 196 plus x squared plus 2 over 4 plus x squared equals 0. And then what I would have done is I would have added that negative fraction to the other side. So you would have ended up with positive 14 on the other side. And the reason I would have done that just simply because when you have one fraction on each side, you can cross multiply. Just a little bit easier to solve that way when you don't have fractions. So that would give me 2 times 196 plus x squared equals 14 times 4 plus x squared. And then from there, distribute, combine like terms, try to get all the x's on one side, things like that. So again, I'll sort of do a ... What you should have ended up with was x squared equals 28, which you would have gotten x equals definitely the plus or minus the square root, but if you go back to our original picture, x was a distance. So let's go ahead and leave that as a positive square root of 28. which you can also realize that 28 is the same thing as 4 times 7. Square root of 4 is 2. So you should have ended up with x equals 2 root 7. Now you can, that was our critical point. You can go through and double check the work to make sure that actually did maximize your viewing angle, which it would have. You could have done a number line, you could have done a second derivative test, any number of things there, but that would have been the distance there. You can plug that into your calculator to get that full decimal if you'd like as well. So hopefully that makes a little bit of sense. Maybe kind of just go back to recap. What I did here at the beginning of the picture, I took theta was the green angle in the picture, and what I did is I took the bigger pink angle, which I called alpha, minus the smaller yellow angle, which I called beta. And the reason why I did that is, again, because those are the only two angles that actually have this right angle in them for the triangle, and you need that in order to use SOHCAHTOA. So that was why you had to use, that's the only way you could use those trig functions. And in fact, actually, Pythagorean theorem was never used here. So once we got theta equaled cotangent inverse of x over 15 minus cotangent inverse of x over 2, then it was quite simple to take the derivative. Took a little bit of work. You're going to have to do chain rule there. The simplification is definitely what's harder when it comes to that. Maybe finding common denominators, dividing by fractions. Don't forget to flip the denominator. All of that stuff is involved from getting this dot, dot, dot down to this next page that I had here. And then all of that simplification from there once you get rid of the fractions. Not too bad. So hopefully that helps.